Hey guys, so today we're going to continue talking about Unit 4 in triangles, and in particular about similar triangles and how you show or what are the methods that we show that triangles are similar. To begin with, however, we're going to start off with a quick warm-up. So go ahead and try this on your own and then continue the video. So I hope you actually tried it on your own. So first of all, they want us to solve for x. And so the first thing we have to pay attention to is the fact that they're already telling us that these two triangles are similar. So one of two things. One, now if these triangles were not one inside the other, so we have this little one here inside this bigger one here. If we didn't have that, then that would make this even more important, because that tells us what exactly goes with what and exactly what matches up. Easy to see that they both share this angle here, which means MK, and if you notice it's between these two, is gonna line up with JK, right? So parts are already corresponding, they're already in the same position, right? So whenever we write our proportion, it doesn't really matter what you get the information from, as long as you keep it consistent, as long as you keep it in order. So here's what I mean. So if I'm going to talk about this this side, right? So what I would set it up as, it would be x plus 1 over 3x minus 2. Right? And then I would set that equal to, now here's what I mean, but you have to keep things in order. Notice how this side came from the little triangle, so the next thing I'm going to put this over from or equal to is that's another side from the smaller triangle. And this this side down here came from the bigger triangle. That means that the last side is going to be this big triangle as well. Now this big triangle consists of two parts. From here to here is 20, and then from here to here is 12. That means altogether is 32. And so then we can go from here, right? So we can go ahead and solve this equation by cross multiplying. So this goes up there, that goes up there, and so then when we multiply over, we have to remember it's everything. So we have to use parentheses pretty much everywhere, right? So once we multiply it over, this is what it looks like, right? So we have 32 times x plus 1 equals 12 3x minus 2. And then from here, it's simply a matter of simplifying this algebraic equation. So we're going to distribute in there, so you get 32x plus 32 equals 36x minus 24. And since I have x on both sides, I'm going to go ahead and subtract. Now, it doesn't matter which way you go. I don't want to be dealing with negative x's, so I'm going to go ahead and subtract 32x from both sides. And at the same time, I'm also going to move this 24 over. So on the left side, I have 56. On the right side, 36 minus 32 leaves me with 4x. And so the last step here is to divide both sides by 4. And so on the right side, I get x. On the left side, I get 14. Alright, so moving on. So these are three ways that we prove triangles are similar. And so what I like to write them as, like whenever they're asking me show or prove that two triangles are similar, I always write this first. And the reason I write it is because if I remember SAS, right? I know it sounds funny, but if I remember SAS, in my head it tells me, okay, SAS means I have three, right? I have side, angle, side, because of the SAS. Then I have angle, angle, and then I have side, 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 right? So each letter, it's an acronym. Each letter stands for one of these things, right? And so we're going to draw some diagrams or some triangles that go with this. So for angle, angle similarity, it's saying if, and I'm going to go ahead and highlight this for you guys, if two corresponding angles, okay, corresponding means they have to be in the same spot, right? So it says if their corresponding angles are congruent, then that is enough to prove that two triangles are congruent, right? So what that looks like is, let's say I have these two triangles here, okay, and I'm going to go ahead and label them A, B, C, D, E, F. Okay. So one thing we have to remember is the fact that if no matter how you draw a triangle, if you know two out of the three angles, you can always find the third, because when you add up all the angles inside a triangle, they should always add up to 180. So if you know two out of the three, we can always find the third one by subtracting from 180, right? And so what it's saying is if you have two corresponding angles, which means that they're in the same location, right? So for this first triangle, it's on the bottom left, second triangle is bottom right, sorry, bottom left. And let's just say we go with this top one, right? So this right here is enough to prove that these two triangles are similar, because I'm shown that one, they're corresponding, and two, that they're congruent. Okay. Looking at side similarity. So it's saying if all corresponding sides are proportional, then we have two corresponding then we have two similar triangles. And so what that's saying is, once again, if I have two triangles, and I'm going to go ahead and label them A, B, C, D, E, F. Okay, so for our purpose, I'm just going to go ahead and label them this way: C, A, B, F, D, E. Okay, so here are the angles, right? And then here are the corresponding sides to that angle, right? So this, right? So what this is saying is if all corresponding sides, so corresponding means in the same relative position, right? So C and F would be in the same spot, A and D would be in the same spot, B and E would be in the same spot, or they would be corresponding. And it says if they are proportional. So remember, to check whether something is proportional or not, we set up ratios, right? And so one ratio we can set up is check C over F, right? So we make that ratio and we simplify, and then we're trying to see, is that the same ratio as A over D, right? And then simplify that, and we're trying to see, is that the same ratio as B over E? If they are, then we conclude that that's enough to prove that two triangles are similar. If one of these is different, either one, then we cannot conclude that they're similar, right? And so then that brings us to this last reasoning to prove why triangles are similar. So it says if two corresponding sides are proportional and the included angle is congruent, then that is enough to prove triangles are similar. So the most important thing here is the fact that this angle, the location of that angle. So it's saying if we have two triangles, and I'm not going to label these, so it says if we have two triangles, in order for these two triangles to be similar, one, the sides, right? So the sides, corresponding sides, so we're going to color code this. So the corresponding sides have to be one, proportional, right? And the sides that you're given, right? So if I'm giving these two sides, the most important thing is the angle between those two sides has to be congruent, right? So that's kind of what I'm looking for, right? So the two sides that I'm given, the angle has to be between those two sides, and one, the angle has to be congruent, two, the sides have to be proportional. Okay, so we're gonna go ahead and practice these one at a time. And so here we're talking about, can we prove these triangles are similar by angle similarity? So remember, to prove two triangles are similar by angle-angle similarity, we only need to show that that two angles are congruent, congruent and corresponding. So let's look at the first example. So for right off the bat, we can easily see that those two angles are one corresponding to congruence, right? But then the next angle we have is 74 and 31. Those are not the same numbers, but they're both missing one angle, right? So we can find that missing angle. And the reason we can find that missing angle is because remember we said whenever we add all the angles inside a triangle, they should add up to 180 degrees. So when we add 75 and 31 plus x is what we're calling that missing angle. Then we get 106, sorry. And then subtract 106 and we get 74 degrees. And so since that angle is 74, we can now see that that's 74 matches, right? So they're corresponding congruent. And then if we wanted to find that one there, we simply do the same thing. The only difference is now the two angles that we're adding is 75, 74, and then x, right? And so this would be 180, 149, subtract 149, and we get x to be 31. And now we can easily see that all the angles are the same, right? But we don't say angle similarity because it's kind of redundant, right? There's no need for it. We know that if we can find two, we can always find the third one. And so that's how you show, right? That's how we show that these triangles are similar. Now here's the most important part. When asked, are these triangles similar, we answer the question yes. How are they similar? We can say by angle similarity. And even more important, you have to state what is similar, right? So we have to write what we call our similarity statements. And so our similarity statement is, so here's what I recommend. The first triangle doesn't really matter. So I can say triangle ABC. I could have said triangle BCA. I could have said triangle CBA. It does not matter, right? What does matter is that second triangle. That second triangle has to match everything from the first triangle exactly. So how we make it match is we notice how angle A is the one that measures 75. So the angle that measures 75 on the second triangle is angle D, so that's where we start with. For the first triangle, it goes to angle 74, which is B. So on the second triangle, 74 is angle E. And so that's what tells us the order that they're going to match. That tells us exactly what lines up with what. Okay, so let's take a look at example number 2. So for example number 2, to start off with, the only angle information they're telling us or they're giving us is this angle here, right? So because they have the same markings, we know that those are two angles that are one corresponding to congruent. Now it is our job to find, can we find another angle in here, right? Do we have any information? Now we cannot assume measurements, right? So we can't say, well, this kind of looks like a 90-degree angle, right? Well, we can't because we don't know if it's 89.9. We don't know if it's 90.1, right? So we cannot assume measurements, which brings us to, do we have any angle pairs? And here we do. We have vertical angles there. And so vertical angles, remember, are always going to be congruent, right? So here we have for each triangle, we have two angles that are corresponding and congruent, which means that I have enough information to show that these two triangles are indeed similar. And so once again, I answer my question. Yes, they are similar by angle similarity. And again, the hardest thing is writing my similarity statement. So again, it does not matter what we start with. We can say VWX, okay? The second triangle is the important one. I started at V, which was the one the angle that they gave me, so I'm going to start at Y. And then I went to W, the one that has no markings. So the one with no markings on the second triangle is Z. And then I ended at X. Okay. So let's look at this third example. This third example is probably the hardest one, or this is kind of like as hard as it's going to get. The reason they're a little bit hard is because we have to identify angle pairs from using transversal lines and parallel lines. Right off the back, however, we see that one, we have vertical angles there, right? So we're starting off with one angle that's already corresponding and congruent. The next thing we got to find is how do we find that second angle? And so remember these little markings, that means that we have two parallel lines, right? So my parallel lines look like this, and so here are my two parallel lines, and then I have this transversal that's kind of going through here, so that's C and that's G, correct? And so what I want to do here is I want to identify, do I have any angle pairs? So here's what I mean. So I'm going to draw this here, right? So those are my two parallel lines, and then here's my transversal, and so that's kind of what I have there. Now if I talk about this angle there, that's not really doing anything because that's not inside my triangle. I want to choose an angle that's inside my triangle, right? So same thing here, that's not going to tell me anything, that's not going to tell me anything. So the only angle that I can possibly talk about that's going to help me here is the angle that's on the interior, the inside right here, right? And so it kind of helps me identify that other angle, right? Yes, these are corresponding if I were to choose this one, right? But this angle is outside. It's not doing anything because that's not inside my triangle. Same thing there and same thing there, right? That would mean that those three angles right there, they're not inside my triangles, so they're not telling me anything. But the angle that is actually telling me something, and I know it's congruent, is right here, right? And so these two angles are going to be one, alternating because they're on the opposite side of my transversal, right? Here's my transversal. And two, they're interior because they're on the inside of my two parallel lines. So the two red angles that I just identified are what we call alternate interior angles. And since my lines are parallel, I know that they are going to be congruent. And that helps me because now I have everything that I need to prove that these two triangles are similar. So once again, we answer our question, yes, they are similar by angle similarity. Angle similarity. And then the two similar triangles are, remember the first one does not matter, so we're going to go C, D, E, no particular reason. And then the second triangle is the one that matters. So the first one started at angle C, which is the one with the red angles. So the one with the red angles is angle G. And then I went to D, the one that has nothing, so F. And then that end up at E. Alright, moving on. So now we're going to talk about side angle side. So remember the key part about side angle side is that the angle has to be between the two sides, right? The angle has to be between the two sides. And what's important about the two sides is that they have to be proportional. Okay, so let's go ahead and get started. So now notice how this right here is the angle that's given to me, right? So those two angles are one corresponding congruent. And then the second thing I have to realize is the fact that the two sides that they're giving me are indeed incorporating or are kind of sandwiching that angle that I need, right? So I have enough to try to show that it's going to be side angle side. The only thing I got to worry about now is, are the sides proportional, right? And so here's what I recommend. Now, to determine which side is corresponding with what, compare the two sides within each triangle. Here's what I mean. So between 8 and 20, 20 is the larger, right? So we'll say large, and 8 is the smaller one, right? So if we were to compare the two sides on the other triangle, 15 is a large angle, or sorry, large side, and 6 is the smaller side. And the reason I'm doing that is because now I can write my ratio, I can write my proportions. I can write small over small, large over large. Notice how both of these numbers came from one triangle, both of these numbers came from the other triangle, right? So I'm not crisscrossing, I'm not mixing them up. And so from here I simply simplify. So biggest number that goes into 8 and 6 is 2. 2 goes into 8 4 times, 2 goes into 6 3 times. Biggest number that goes into 20 and 15 is 5. 5 goes into 24. 5 goes into 15, 3. So since I just proved, or I just showed that they are similar by showing that they're proportional, then I can conclude that yes, they are similar by side, angle, side similarity. And once again, the important part is write your similarity statement. So we're going to go K, L, J for no particular reason. So the second one has to go in that same order. So it started at K, which is the angle they gave me. So the angle they gave me here is N, and I went along the larger side, right? So along the larger side takes me to P, ends at M. Awesome, right? So let's look at this second example over here. Now, once again, here I have vertical angles, right? So anytime you can identify vertical angles, just go ahead and identify your vertical angles. Now, we don't know any other angle information, right? We don't know nothing there and nothing there. So we can't assume measurements, right? So same thing on the other triangle. We don't know any information about those angles, so we cannot assume anything about them. Now, the second thing is, remember, if we're trying to use side angle side, this angle has to be between the two sides, correct? So notice how this side is what's given to me and this side was given to me. I do not know that angle. This side was given to me, this side was given to me. I do not know that angle. And even worse, I don't know this side and I don't know this side, right? So here, this, yes, I have an angle and I have two sides, but they are not in the order that I need them to be. They're not sandwiching the angle that I need to prove that they are similar by side angle side, right? So the official answer would be, I would say I don't have enough information to prove that they're similar, but we're gonna go ahead and say where they are not similar. So looking at this third example, once again we have parallel lines, which is telling us we're gonna have some kind of congruent angle somewhere, right? And so our job is to identify where those congruent angles are. And so here we have our two parallel lines, and this is our transversal. And so if that's the case, this angle, that angle, none of those three angles are inside my triangle, so they're not telling me anything. And so here, this angle is inside my triangle, and that's going to be corresponding congruent to this angle here. So those are my two angles that I get from the parallel lines and the transversal. And so if we notice this angle, sorry, this side here, this side, and this side, and this side, they're all kind of, for lack of better words, sandwiching the angle that I need, right? And so I'm going to put, so I have enough information to try to show that it's going to be similar by SAS. The only thing I got to show now is that are they proportional, right? So we're going to do big over big and see, is that the same as my smaller side over my smaller side? So if I put 54 over 33 in a calculator, I get roughly 1.64, and I'm trying to check, is that the same as if I were to put 36 over 22 in the calculator? And indeed I get 1.64. So yes, they are similar by side angle side similarity, and the two triangles that are similar are MPC, similar to PQR. Alright, so moving on. So side, we have to check all three sides, and we have to check whether they are similar or not. So here, perfect example of, we have to check, we have to determine what side matches with what side, right? Because we can't say is 3 over 10 the same, right? We have to make sure that they're corresponding. So what I would do is compare the three sides within each triangle. And so I'm going to label that small, medium, large. And same thing here. Between these three sides, I have small, medium, and large. And so now I know which side corresponds with which side. In other words, which side goes with what side. So I'm going to check small over small, so 3 over 6, and then simplify it, I'm going to do that here. So 3 over 6. Simplify, and is that the same as my medium over my medium? And is that the same as my large over my large? Now if I simplify, they're all simplified down to 1/2. So in this case, yes, they are similar by side similarity. And the two triangles that are similar is, remember, the first one doesn't matter, so I'm going to go Q, remember the first one doesn't matter, so I'm going to go with Q R P, and similar to triangle T U S. So let's look at this second one here. So once again, this one's a little bit more difficult to determine what side goes with what, but if we were to label each one, so here's my small, medium, and large. Looking at this second triangle, I have my small, medium, and large, right? And so once again, here I'm going to set up my ratio, so small over small, so 5 over 3. Is that the same as my medium, which is 12 over 7? And is that the same as my large over large? And right off the bat, I can already tell that they're not. But if I were to put it in my calculator, 5 divided by 3, I get 1.67. And I'm trying to see, is that the same as 12 over 7, which it is not, 1.7. So because they're not the same, they're not proportional, that we can conclude that they are not similar. Okay. Looking at this third one, yes, third example, yes, we have all the sides, right? So side, and then side, right, for the little one, and same for the big one. But we also, because this angle is being shared by both, because we have the two triangles in one inside the other, right? So we really have two options here. We can show, or we can try to show, is that they're similar by side angle side, or by side side, correct? And so to do that, we're gonna have to check, are the two sides similar, or are the three sides similar, right? So we create our ratio. So here I'm gonna do 20 over 28, and so that's coming from here. So 20 is this side of the small triangle, and so that same side on the big triangle is 20 plus 8, which gives us the 28. And so I'm trying to check, is that the same ratio as the other side? So 15 over 21. Again, 15 came from this little triangle, 21 came from this big triangle. And then I'm going to go ahead and check the third side, and it's going to be 40 over 56. Now here I don't really need a calculator, I can simplify these. So 20 and 28, biggest number is 4, so that's 5 over 7. Biggest number between 15 and 21 is 3, so that's 5 and 7. Biggest number is 8, and that's 5 and 7. So because they all have the same ratio, right, and I showed on the diagram that the angle is between the two sides, I can say yes, and we can choose, right? So I can say by side angle side similarity. So if you're going to show by side angle side similarity, mark the diagram saying that they're congruent, and then you have to show that the two sides that are on each side of the angle are proportional. Or by side similarity, if you're going to choose side, then you need to check the ratio for all three. And then again, the triangles is WXV is similar to triangle WYU. Okay. So let's go ahead and try this first example. Okay, so here's kind of how I would approach every single problem. Is remember, there's three options. It's either going to be angle similarity, side angle side, or side side, correct? So if I'm trying to use angle similarity, then I need to have two angles, right? In this case, the only angle that I have is one. There's no parallel line, so I don't have any other angles. There's no vertical angle, so I can't do that, right? So since I only have one angle, I cannot use angle similarity. This last one, I don't know the third side, and there's no way of me calculating it. So since I don't know one side, then I cannot use side, 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 because if I wanted to use side, 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 I need to know all three sides. So the only possibility is its side angle side. Now, the only thing now I have to check is, are the sides proportional, right? So this little side here is 32. This bigger side is 42. So that's the ratios I'm going to check. So I'm going to put 32 over 42. And I'm trying to see, is that the same as the other side? So 40 over 52.5. And so I'm going to go ahead and put this in my calculator. So 32 over 42 simplifies down to 0.76. And then 40 divided by 52.5 simplifies down to the same 0.76. So in this case, I conclude, yes, they are similar by side angle side similarity. And the two triangles that are similar are triangle NHG, similar to triangle NML. Alright, looking at this last one. So once again, I approach it the same way, right? So can I show angle similarity? Can I show side angle side similarity? Or can I show side side side? So the only angles that I have here are vertical angles, right? So because I don't have any parallel lines or anything like that, I cannot talk about any other angle. So that option is out the door. If I want to talk about side angle side, then the two sides have to be sandwiching the angle, which they do, right? And then I can also use side 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 because I know all three sides, right? And so let's go ahead and do that. So I first have to show, are the angles proportional, right? Or sorry, are the sides proportional? And between 10 and 12, between 12 and 10, 12 is the bigger one. Between 18 and 21, 21 is a bigger one. And then between 10 and 18, they're kind of the same, right? So 10, 18, and I simplify and trying to see, are they the same? So, or sorry, are they the same ratio? So 12 over 21, biggest number is 3. 3 goes into 12, 4, and then that's 7. Biggest number between 10 and 18 is 2, and that's 5 over 9. So here we can say not similar. Even if I tried side side side, right? 8 over 14, if we simplify that, biggest number is 2, that's 4/7. Even though both of these match up, the other one does not. And remember, they all have to be proportional in order for me to show that triangles are similar. Alright, so last set of problems. We have vertical line, we have parallel lines there, and right off the bat, this angle is being shared, right? So here are my parallel lines, and I have my transversal there. So it can talk about this angle here, right? And then I have my two angles that I need to prove that they're congruent, right? Because these are my parallel lines, this is also a transversal, which is telling me that this angle is also congruent to each other or corresponding. And so the first one is, yes, they are similar by angle similarity. The two triangles that are similar are X, Y, Z is similar to triangle X, A, B. Alright, so looking at this last one, again, we have parallel lines, which means that this is my transversal going through both of these, right? So here are my two parallel lines, here's my transversal. Again, that angle, and that angle tells me nothing, right? Because they're not inside my triangle. This angle, however, is inside both of these triangles. They are corresponding, they are congruent. So I found the angle that I need. And then notice how the sides that I'm given are the sides that kind of sandwich or squish the angle or create that angle, right? And so I have to check, are they proportional? So I check 20 over 32, and is that the same as 14 over 22.4? So I'm going to put in my calculator, 20 divided by 32, and I get 0.625, and I'm trying to check, is that the same as 14 over 22.4, which it is. So in this case, I can say, yes, they are similar. They are similar by side angle side similarity. And the two triangles that are similar are JTK similar to KSL.